Hello everyone, welcome to ashatech.com. In this discussion we are going to discuss vectors. Now, the guiding question says find the angle between vector A equal to 2i plus 2j minus k and vector B equaling to 6i minus 3j plus 2k. Then part B of this question says if vector P is equal to 4i plus j minus 2k and vector Q is equal to 3i minus 2j plus k and vector R is equal to 2i minus 2k, then find P minus 2q being crossed with R. And also part 2 of this Roman 2 of this part B says find the magnitude of this cross product. So let us find the solutions to this problem. Solution 1 says we have vector A and the vector B and they want the angle between the two vectors. The angle between vector A and vector B. So for us to determine the angle between the two vectors, we use what we call a scalar product or a dot product. So therefore, from the fact that vector A dot vector B equaling to magnitude of that vector A times magnitude of vector B times cos of the angle in between the two, whereby theta is the angle between the two vectors. So now let us find the magnitude of A. Magnitude of A is actually, since this is a three-dimensional vector, then it would be x squared plus y squared plus z squared, everything under a rule. So that means I'm going to use the values for x, that is the I. So we have 2i plus 2j minus k. So it means the magnitude for vector A will become 2 squared plus 2 squared plus minus 1 or negative 1 squared, because the coefficient of k is negative 1. So everything to power a half or under a root. So if I substitute in these values, I will find that I have square root of 9, which equals 3. Then magnitude of vector B will also equal to, remember it is 6i minus 3j plus 2k. So the magnitude of this vector becomes 6 squared plus negative 3 squared plus 2 squared under a root or to power a half, which will equal to square root of 36 plus 9 plus 4, which will totals up to 49. So take the square root of 49. This will give you 7. And now what about vector A dot vector B? So in a dot scalar product is element-wise multiplication. In other words, those products in the x dimension are multiplied together, those in the y dimension are multiplied together, and those in the z or the k dimension are multiplied together. Therefore, vector A dot vector B will be 2 times 6 plus 2 times negative 3 plus negative 1 times 2. And this is equals 12 minus 6 minus 2, which equals to 4. So from equation star, where we have the fact that A dot B is equal to magnitude of A times magnitude of B, cos of the angle in between them. When we substitute in that equation, it becomes, because A dot B is 4, it will equal to 3, which is the magnitude of A, times the magnitude of B, which is 7, then the cos of the angle in between them. That means the theta will be the cos arc or the cos inverse of 4 out of 21, which gives you 79.02 degrees. So 79.02 degrees is the angle between the two vectors. So let us go and answer part B, Roman 1. Given the vectors P, Q, and R, we find P minus 2Q cross R. So let us first find P minus 2Q. So this can be expressed as if we express them in the form of column vectors, this will be 4, 1, negative 2, minus twice of 2. This 2 will be multiplied into vector 2, so that I have 4 minus 2 times 3, which is 4 minus 6, and this would give you negative 2. Then 1 minus 2 times negative 2, this would be actually 1 plus 4, and this would give you 5. Then this is negative 2 minus twice 1, which would give you negative 4. So that is p minus 2q. So if we let that w, that p minus 2q to equal to vector w, then it means this w is equal to negative 2, 5, negative 4. So if we are to cross it, then it means we shall have a cross of w crossing r. So that means using the determinant method, we are going to use determinant method to find the cross product of w by r. So we create a 3 by 3 matrix with I, j, k. Then we put the constituents, the members of vector w, which is negative 2, 5, negative 4. Then members of vector r, which will be 3, 0, negative 2. Because r is given as 3i minus k, so expressing it in a 3 dimension and bringing out the j, r will be 3i plus 0j minus k. So using the determinants method, we are going to be able to find that cross product. So this will be, I take I, then I make sure that I create a line here and a line here, then I take the contents that are adjacent the I. So these are the 5 minus 4, 0, negative 2. I put them here. Remember, I take a plus, a minus, a plus. So you have to be consistent with these signs. The sign conversion is a plus, minus, plus. So this is plus I into 5 minus the I times the determinant of 5 minus 4, 0, negative 2. Then minus j also, j, this is j, so I will make a horizontal line here and create a vertical line. So wherever those lines are passing, those contents are going to be out. Therefore, if I take a j, then I will take the determinant of a matrix of negative 2, negative 4, 3, negative 2, which are these members, then plus k into the contents that are adjacent to the k. In other words, I create a horizontal line passing through the k and a vertical line passing through k, meaning that whatever members are remaining is the matrix whose determinant I'm going to get, then I multiply it by k. So this will be k times the determinant of the matrix of negative 2, 5, 3, 0. Negative 2, 5, 3, 0. So therefore, it means W cross R will be, I look for the determinant of this matrix, 5 minus 4, all of these matrices. So to get the determinant of a 2 by 2 matrix, it means I get the contents of the major diagonal, I multiply them together, and I subtract the products of the minor diagonal. I repeat. To get the determinant of a 2 by 2 matrix or this matrix, I'll get the contents of the major diagonal, which is 5 minus 2. I multiply, 5 times negative 2. Then I subtract the product of the contents in the minor diagonal, which is 0 and negative. So it will be 5 times negative 2 minus 0 times negative 4. I cross, that is I. Then I take a minus. Again, negative 2 times negative 2. Then I subtract negative 4 times negative 3. I cross, and that is my j component, plus Again, negative 2 times 0, I take away 5 or 3 times 5, and that is a k. So when I add all these contents together, I'll come up with a product, a cross product, or a vector which is negative 10ij minus 15k. So it means a cross product will always give you a vector, unlike a dot product that will always give you a number. And therefore, this is why we call it a cross product or a vector product, and the dot product we call it a dot product or a scalar product. So that means if I have p minus 2q crossed with r, then I'll get negative 10I minus 16j minus 15k. What about getting its modulus? Its modulus, therefore, using the fact that the modulus will always be the square root of the x component squared plus the y component squared plus the z component squared, if it is a three-dimensional vector. So if it is a two-dimensional vector, then there will be x squared plus y squared under root. So since this is this p minus 2q cross r is a three-dimensional vector, then therefore its modulus will be minus 10 squared minus 16 squared minus 15 squared, and this is going to be 100 plus 256 plus 225, and if I take a root, then it will give me 24.10 units. Therefore, the magnitude of p minus 2q by r will give you 24 units. Thank you so much for watching. See you in the next lecture.